Alright, hello everyone. So in this video, I'm going to try to explain how my project works. So the project that I'm talking about is, well, the entire thing is called an aeroponic system, but I divided it so I also have some kind of automation aspect to it. So in this project, I'm using a pH sensor to monitor the pH of a solution that I'm going to be distributing to those plants. But I'm using a PID controller in order to do this. So I'm using an Arduino Uno and two little pumps using 12 volts DC, and we're just going to see how I made this happen. So let's take a look. Alright, so let's take a look at the schematics. So over here you've got the Arduino Uno, and I've taken the liberty of labeling out the pins. So over here you got A0, which is an analog pin used for to get the values of our pH value. And then I also labeled pin 3 and 6, which can give out PWM signals. So pin 6 will be used for a pH down, and 3 will be used for a pH up. And over here you want to make sure that you connect this to ground and this to 5 volts. And be sure to use the same ground here to this ground here, which uses 12 volts instead of 5 volts. So take that into account. And yeah. So what happens? Now, the PWM signal will be sent to the gate of our MOSFET here, which is an N-channel MOSFET. And at the drain, we will have a motor, which gets 12 volts here, and here it will either complete the circuit or break it, and that's how we're able to drive our motors. And essentially we're able to control our motors using this PWM signal because of the switching on and off, which will be quite fast. And as a result, this motor, which is a pump in fact, will deliver the liquid pH down into our basin of water. And the same thing happens essentially for a pH up. So as you can see, it goes through a resistor to the gate of the MOSFET and brings a different type of liquid into the basin that we're trying to control. So in here you've got our pH sensor, which just dangles and just measures the pH value. And this pH sensor board, I'll give you the details on it and the code to operate it properly. Other than that, be sure to also connect it to ground here, the same ground as this one, and use a 5 volt supply. And I think that's pretty much it for the schematics. Alright, so over here we have our Arduino. It's connected to our computer currently. And over here we've got our 12 volt power supply coming from the wall, which is connected to an adapter. Over here you've got the ground connected to our breadboard here. That's how they share a common ground. Here we've got the 5 volts connected to the pH sensor board that you can see right there. And the analog is this wire right there, which goes to A0, just like in the schematics. Now, over here, you may or may not see it properly, but you've got one MOSFET here and another here. They get 12 volts from an external power supply. So that's, yeah, they get it from here, from the breadboard itself. And the motors are connected from the positive terminal to the drain, and then the drain is over there, and your PWM signals from the Arduino are coming in from there and going to your gates, which are also going through a 330 ohm resistor, and the source are connected to ground, which are all connected together. So that's what the wiring looks like. Pretty simple, but yet effective. So this breakout board, let's take a closer look and then plug it. So as you can see, Um, I did not make this, of course, so I'm going to show you where I got this and where you can get it and the code to operate it. So as you can see, there's a couple of pins. You've got ground, V plus over there. So make sure you use 5 volts here and connect ground to these two using the common ground that you've used throughout your entire circuit. And the only pin that we're really interested in is P0 or PO. That's our analog value for the pH. It could also measure the temperature, but we are not interested in that data. So we're only using this pin. All right. So where we got this board and the probe itself is from our local electronic shop, which is called Abra. This is not a paid promotion by any sort. It's just where we got it from. So that's exactly the same board that I have in real. And they put in this link here, which sends you to this page and shows you how to use a pH sensor with the Arduino. And they explain, they go in really good detail. They show you some data, like data specs and pinouts, and they show you how to calibrate it, which is also very important. But most importantly, they show us the code. So this is essentially copy-pasted from here onto my Arduino code. So I do not want to take full credit this entire thing. No, this code comes from them, and that's that. So yeah, you just got to make sure that your pins are corresponding to what's in the code, and yeah, that's it for that. As for the MOSFET that I'm using this. You could find it on DigiKey. This is what it's called, and it's good for motor drives, as you can see there, and gate, drain, source. If you want to do your connections using this chip, go for it. I recommend it. I had no problems with it whatsoever. So it's the F3055L. And yeah, so let's take a look at our code. Now, if you haven't checked out our video about PID for controlling a motor using an encoder, I highly recommend, because we're going to be recycling some elements from there and implementing back into here. So over here, we're going to define PWM1 as our pin 3 and PWM2 as our pin 6. But I highly recommend you commenting which one is which. So right here, let's put up or down or whatever, which is which. You have to find out which one means which. So over here, that's the copy pasted stuff, and we added this here. That's part of our PID code that we used before. So this is copy pasted. Now here I set int target to 7, but I could put it between 0 and 14. But realistically, it's most likely going to be between 3 and 12, because our pH solutions don't allow us to go beyond those 2 points. So you could go anywhere between like 3 and 12. So I have it set at 7, but you could change it. These you will need to change. These are susceptible to change from one system to another. So you want to calibrate it properly. And yeah, so it's exactly the same as we've done in the PID video. I really recommend you watching it. However, we are using 2 motors. So we are saying essentially if our power is greater, well, if our U is greater than 0, we want a certain motor to start going. If it's the opposite, we want another motor to start running. So that's what this is doing right here. So if it's smaller than 0, you want our motor 1 to go on. If it's not, then you want our motor 2. So this corresponds to one motor being pH up delivery system, or the other is pH down. Um, and that's that. And for these functions, we slightly modified it. We took out a lot of things from there because we didn't need it. So in this case, you only really need your power and your which pin you're talking to. So that's all you really needed. And as a matter of fact, you could probably just copy paste this line into this here instead of making a function and calling on it. That might be simpler, but again, I recycled the code from the PID video that we've done before. So this is how it works, and let's try to see it in action. So over here we have water, and we're going to see what happens if we put it in a solution that has a pH that's up. So let's take a look. So if we go from the water solution to the pH up solution, we will see a change. Yeah, there you go. You can see a change in the PWM signal just like we will see with the pH down. So this also drives another motor which will deliver the solution responsible for the pH up into the bucket of liquid that we're trying to control the pH value of. And let's put it back into the water, and you can see it decreases its value until it's gone. Alright, and let's see what happens when I put it in a solution that has a pH that's lower. Alright. So moving it from water to pH down solution, you're going to see that happening. And now if I put it back to the water, you should see it decrease the PWM value until it's gone. So that signal is sent to the MOSFET that essentially drives the motor which distributes the pH down solution. Alright, so let's take a look at what happens when we take our pH sensor value from the water basin to our pH down solution. So as you can see, it dropped pretty low to about 3. So this is what we expect to see. So we know our things are working out alright. Now, let's put it back into water. Maybe agitate it a little. Yeah. Slowly but surely, it'll get back to where it was. Now, let's take a look at what happens when we put it in a pH up solution. Yeah, so you can see it skyrocketed to like what, 10, 11? Yeah, it's pretty high. So that's how we're able to control the pH value. As you can see, we've set a target of about 7. That's what the blue line represents. And let's put it back. So our solution currently is a little lower than our target, so it should try to put pH up solutions into our basin to get it to that level. So we will see shortly that into effect. So right now I've lowered the set value to about 5.5, so it should try to go up because as you can see the red line is above the blue line, which is our target. So actually no, it should try to go down. My apologies. So what you're reading in the red is our value currently, and what you're seeing in the blue is our target. So let's turn on the power. So as you can see, since it's really close, it's the PWM signals, you can't they can't really be activated. Now if so, let's try to go 4. Yeah, upload. No. Okay, so let's take a look at the serial plotter. So our value dropped, and let's check it out. go. So now we could see a small and steady flow of our pH down liquid. However, we're not stirring the liquid enough. I see it went past it, but it's close enough. So it got to the value, and now it's not spraying anymore or anything. But now let's try to put a bigger value. Let's say 7 and see what happens. Okay, compile, uploading. Done uploading. Let's turn on the power. So it's trying to reach that value. Squeeze it, squeeze it. Yeah, okay. So let it go and stir it. So we should see our value slowly going up. It wasn't concentrated enough. So as you can see, it's slowly but surely going up, and it will try to reach it. And eventually it'll try to reach it. But now it's kind of dripping, so I think it thinks it's close enough. But these values for the PID, that's what you got to change in order to prevent undershooting, as you're seeing right now. So that's about it for this. So yeah, so the pH value is currently set for 8, and right now it's about at I would say about 5 pH value. So you got a difference of 3 in the pH scale. So let's turn on the output. Oh. So as you can see, it's dripping on there. The pH value is slowly rising, but it's not getting quite there. But that's because of the PID parameters that you would need to adjust. Now, let's turn off the output. Now let's try to go with a lower pH value. Let's try with 2. Because it's already at like 5, 6. It wasn't quite at 8, so it's already quite low. So it's done uploading. Let's turn on the output. Oh, there you go. Oh, okay. Stir it, stir it, stir it. Stir it, stir it, stir it. Yeah, there you go. Now you can see it. It's going down, down, down. It's trying. And you can see the flow it's getting weaker and weaker. Yeah, until it achieves the minimum value of pH. So we could turn off the output. So the minimum pH value that we could achieve is about like I think 3.5 if I read the label properly. Is it? No, it's much higher. Yeah, so you need to adjust like the proper PID values, the constants, in order for this to work. So if it's above the pH value, it tries to shoot pH down, and if it's under, it tries to shoot pH up. Yeah. So that's it for this video, guys. Thank you.